Okay, so we're going to take one more look at an example here that involves acceleration. This time, we're just not going to be solving for acceleration. We're going to be solving for something different within that formula. So example 1.3.3 says a racehorse takes 2.70 seconds to accelerate from a trot to a gallop. If the horse's initial velocity is 3.61 meters per second west, and it experiences an acceleration of 2.77 meters per second squared west, what is the racehorse's velocity when it gallops? So really, we got to think about the fact here. It goes from a trot, it goes from, in this case, a trot to a gallop. So if we're looking at that velocity when it gallops, that velocity when it gallops is really going to be that final velocity that we're looking for. Okay, so in this case, it says that the horse's initial velocity is 3.61 meters per second in the west direction. The next piece of information that it gives us is the acceleration of the object. So the average acceleration is 2.77 meters per second squared, again in that west direction. And then the last thing that we need is this thing right back here from the very start of the problem, and that's the change in time that it took 2.70 seconds. Okay, so again, we know we're looking for that final velocity of our object. Okay, so we know we need to use our average acceleration formula, which says the final velocity, subtract that initial velocity, divided by that change in time equals that average acceleration. Okay, we're looking for the final velocity in this case, so we need to isolate for the final velocity. So the first thing I need to do is I'm going to multiply both sides of my equation by time. That cancels it out on that right side of the equation, meaning on the left side I now have the average acceleration times that change in time equals v final minus v initial. Okay, remember again, we're looking for that final velocity. We subtract initial on this side, so to get rid of it on the right side, I then have to add the initial velocity, and I'm going to do the same thing to the left side of the equation. So that means my final velocity is now average acceleration times time plus the initial velocity of the object. Okay, so let's go ahead now and we can plug in our values. The acceleration was 2.77 meters per second squared west. The time was 2.70 seconds. So that gets multiplied by that average velocity. And then we're adding in that initial velocity of 3.61 meters per second in the west direction. Okay, so 2.77 times 2.70 gives me 7.479. Notice if we look here at the unit analysis, you get meters per second squared multiplied by seconds. So that cancels those 1 second there in the denominator. So you're left with meters per second in the west direction, which is exactly what we want, because then we can simply just add our initial velocity of 3.61 meters per second west. Because both of these directions are the same, we don't need to worry about changing any of them, so we can just add these values together. So we get 7.479 plus 3.61 gives me 11.089 meters per second west. Okay, we do need to go back though and look at the significant figures. So 2.70 has 3 sig figs. 3.61 also has 3. So does 2.77. So we need to round our final answer here to 3 significant figures. That means with that decimal place, we're going to look at rounding to this position right here. So with the 8 behind it means we're going to round up. So we're looking at a final velocity of 11.1 meters per second in the west direction.